Hello, grade 12s. Hopefully, you guys have had a good long weekend and you're ready to get back to work. So, the new units combinations, we're going to be looking at a variety of situations, but the main focus is going to be situations where order does not matter. So, in the previous unit, we had permutations where order matters. Now, we're doing combinations where order does not matter. So, for example, you have a contest and you want first place and second place. Okay, that's order matters. Or you have a contest and you need two representatives from your class. That does not have order. There's no first place and second place, it's just two people. So there's the main distinction, and the expectation is that moving forward you'd be able to distinguish between order and not order. But the fortunate thing for you is that this unit we have order does not matter anyway, so we're going to be going through the unit without order. So before we get to that, we're going to do some basic kind of review, some stuff that you've probably seen before. It's a little easier, and then next week we'll get into the actual mathematics of situations where order does not matter. So some of the tools that we're going to cover today and this week are going to help you in the future, and you're definitely going to need them. So here we go. Okay, so Unit 5 combinations, and we're talking day 1, set notation, Venn diagrams, and the idea of inclusion and exclusion. Well, here we go. So set notation, Venn diagrams, we've got a set is a collection of distinct objects. The objects themselves are called elements or members. So a set could be a class, and the elements could have been the students in the class. Sets are named with uppercase letters, and members are listed in brace brackets. So capitals for the set, brackets for the elements. If two sets have no elements in common, they're called disjoint. So if you had two period 1 classes, you couldn't be in both of them. So those two classes would be disjoint because no student would be in both of them at the same time. If you had two sets, well, you'd have 3 sets of the major grade 12 university math courses. You could have students in multiple classes. So some people could be taking data and functions or data and calculus at the same time. That means those sets would not be disjoint because people are in both. So X and Y are disjoint. There's no numbers that are in Y and there's no letters that are in X. So they are disjoint. Set with no elements called the null set, the empty set. To denote the number of elements in a set, we write n of A. So n is just the number of elements in group A, or it could be classroom A. So that class has 30 students. The n of A is 30. If all the elements of one set A are also elements of another set B, then we say that A is a subset of B, where B contains A. Basically, if all the students in data are also in grade 12 university math as a group, then the data class is a subset of grade 12 university math in general. So the set university math has data class as a subset of it. So if A is X, Y, and Z, subsets could be X or Y or Z or some combination of the two or some combination of the 3 or the null. Universal set S contains all the sets we're interested in for a given situation. Group of students meet regularly to plan dances at St. Andre. Anna, Brian, Charles, and Deborah are on the dance committee. Brian, Charles, Eric, Frank, and Gina are on the student council. Hillary and Irene are not members of either group, but they attend meetings as reporters. So you have a group 1, you have a group 2, you have a group 3 with Hillary and Irene. And the challenge is that in group 1 and group 2, there's overlap. Some people are in both groups at the same time. So if you wanted to know how many people actually showed up to this committee meeting, you'd have to add up all the people in the dance committee. You'd need to add up all the people in student council. You'd have to add Hillary and Irene. But you need to be careful not to double count people in both groups. So there's people that are in dance committee and in student council. And the Venn diagram on the right-hand side shows 2 circles. The circles represent the dance committee and the student council. And the overlap is the people that are in both groups. When you're filling in a Venn diagram, always fill in from the middle. So the first thing you'd want to do is figure out who's in the dance committee and student council and fill those people in first. Where on the diagram would you put the initials representing the students who are on the dance committee? You'd put them into the circle with DC. Student council, the circle with SC. On the dance committee and student council, the area in the middle that's overlapped. Not on either dance committee or student council, somewhere in the rectangle, but not within the circles. So Hillary and Irene go in the box, but not inside the circles. You got to figure out Brian is in both groups. So he'd be in the middle. If there's anybody else in both groups, you have to take a look, list them, and move on from there. And then you'd count up how many people total were in the committee. Committee 1, the dance committee, committee 2, the student council committee, and then the visitors. But you'd have to subtract Brian because you counted him twice. So subtract him once because you counted him in both groups. Actually, Charles as well. Brian and Charles are on student council. So Venn diagrams used to show relationships between sets. Universal set is shown as rectangle. Circles to represent the other sets. You've got a union. 2 sets, A and B. So that means you're in A or B. That's the union, A or B. That's what A or B looks like. So anything within the circle of A, anything within the circle of B, and anything within the overlap is A or B, the union. The intersection is A and B. It's only the overlap part. So intersection is just the overlap, whereas union is anything in either. So let's just go back, look at the union and the